What we're going to do right now is go through the first part of chapter 6. We're going to do this in two videos. Chapter 6 is about structured design. And so where we're going to begin is with the need. Why do we need to do the techniques that are talked about in this chapter? Well, basically, the reason we have to do it is because modern software is just huge. It's truly unbelievably large. And in fact, it's so large that no single person can possibly understand a modern piece of software, okay? So that might be a little bit disconcerting when you think that the airplane that you're flying on, for instance, has fly-by-wire flight controls, and there's no person alive who truly understands how that software works, okay? Let's quantify this problem. Talk about the lines of code, the number of lines of code that there are in various pieces of software. So first of all, there's the processing software. So that's the program that we're using to write our programs is about 200,000 lines of Java code. Okay, that seems really huge to us, I know, given that our programs have maybe been, what, 100, 200 lines long to this point. But that's actually very tiny. Think about this. The Boeing 777, its fly-by-wire flight control system has about 2 million lines of code. And the Windows 10 operating system that I'm using on my home computer here has about 50 million lines of code, okay? And if you think about all of those lines and how they could all be different branches and loops and things like that, it's just too huge. You can't consider all the different things that might happen in that process, okay, or in that program. So that actually started to occur to us in the late 1960s and early 1970s. The problems that we were looking at that time, or the programs that were being produced, were not that large, but they were large enough that the results were starting to fail or be over budget or be very buggy. And so the software development community created software engineering techniques to do things better. And the two that we're going to look at in this chapter are, first of all, structured design, or the concept of modularity. And in this concept, what we're talking about is we're going to design our programs so that the components of our software are small, reusable, easy to understand components or subprograms or modules that we put together sort of like Legos to build a larger system, okay? And so in our class up to this point and until chapter 8, those sub-pieces are largely going to be methods. When we get into chapter 8, we'll talk about how to do classes to make our modules. And the second component that we're going to talk about in this chapter is top-down design. And this is a divide and conquer technique where we take a larger problem and break it into a series of smaller, easier to understand sub-problems, okay? So we might illustrate that like this. We have a problem up here, and then we have a series of sub-problems. We broke this into 3 sub-components, and in this particular situation, this problem maybe is too large in and of itself, so we break that down further into 3 sub-problems, okay? So that's the idea of top-down design. Now we're going to look at those in the context of this game called Solo Pong. So we're going to go through more or less an entire Ratus process on this program and see how we might divide our problem into smaller subproblems and write modules that solve each of those subproblems, okay? So here's the problem description, the recognize phase for this. What we're going to do is create a Pong-like game for one player. So it'll have a paddle that's controlled by the player's mouse movement and a moving ball. There'll be walls on the top, left, and right side of the window. So north, west, and south if you want to use cardinal directions. And the paddle will be toward the east. The ball will bounce off the walls. And this program at this point doesn't have to keep score or have sound effects or anything like that. You're actually going to do those when you do the programming assignment for this chapter. But what it does do, if the ball goes off the east side of the display window, then the game will exit. Okay? So we might start with something like this. Just draw this on a piece of paper or on a napkin or something. just a sketch of what the game will be. We've got a paddle over here, we've got our walls, we've got our ball, and then we'd go from there. Okay? Now, before we go into the actual design, which will be the next video, what we're going to do is do a live demo of this system. And obviously, in a real situation, you would not have that option because you haven't built the program yet. But I just wanted to show you how this will work. Now, I happen to get a really unfortunate random number here from the ball. You can see that it's bouncing in a really askew manner. But in any case, I'll let it ricochet off the walls. When it gets over toward the paddle, eventually I'll bounce it back. Boom. And then if we waited around long enough for it to get back to the other side of the window, when it goes off the east side, the program would end. Okay? So that's how our solo pong piece will work. In the next video, what we're going to do is start going through a structured design process, a top-down design process to talk about the different methods and variables and things that we're going to need for this game. All right? So see you next time.